Hello. Hello. Yes, can you hear me? Yes. So we finished yesterday. No, I didn't finish. We started just a problem. I will show you now. And this is the hopefully the last problem in the chapter. Yes, here, right? So can you see the screen? Tell me, please. Can you see the screen? Can you? Yeah. Can you see the screen? Please respond me. Please answer me. Please answer me. Can you see the screen? Yes. No. So last class we were starting the triangular load, and I explained here how to find the reaction force of the triangular load. Right. First, you find the area. Find the area. The area of the triangular load is the area of the triangular load. The area of the triangular load is the actually total load, and this total load work at the center of the triangle, and center is the from the base it is 1/3 distance, and from the top it is the 2/3 distance, and then we got the base, and then you take the moment. You take moment at A and you find the RV A. Where is 18? Here is the 18, and here is 19. Then we stop there. Now today we will stop here, right? After the here we already got the we already found the moment. Total load is this, and then we got the 9 meter, and then we got how much we got this here we got the 9. RA reaction is 9 and R reaction 18. Fine. Now actually our target is to draw shear force and bending moment diagram. Shear force diagram and bending moment diagram. Now what is the shear force diagram is, now to shear force diagram, first we have to calculate the reaction force. Reaction force we have to calculate, and then we already calculate reaction force. Second is something new. Now something new is uh, first new things is we draw here shear force diagram, okay, 0 0, and then at the point at A, and left side we know last little bit left side it is 0, we know already, we learned. VAR little bit right side, and when we go little bit right side we found this 9, so plus 9 plus 9 force we have, so we go upward 9, we go upward 9. All right, so we got the what 9, right? Now after that what is happening there? Every point our load is downward, every point actually it is decreasing. So our shear force diagram is start here, and another thing is I taught you before, I show you the diagram at the end of the slide somewhere here, right? If our load diagram is uniform diagram, if our load diagram is uniformly varying like this, then our our shear force diagram will not like a straight, will not like inclined. It will be kind of parabola like this, kind of parabola. So it is not a straight, actually it's wrong. It will be parabola. So if it is our parabola, and then bending moment diagram will be cubic. So we are here, we have to follow this. Now if it is the now what will happen, how we can find the shear force diagram, how to draw the shear force diagram for this problem. Now here, so it will be, sorry, where here my pen is here. So it will be, now it will be not like this, it will be not like, it will be something like, parabola, like this. Okay, parabola, it will be like this something. If it is like this, now how to calculate, now how we'll calculate. To calculate, we don't know, but there is a trick. What is the trick? Suppose the shear force at C point will be 0. C. Now you see the shear force is decreasing. It will decrease because all force is downward, right? And here decreasing, and here it will be, here is positive and here is negative. So somewhere it will be 0, then it is negative. And we assume the somewhere that point is C, and it is x distance, we assume. So it is x distance, we assume it is the x distance at C, we assume. So suppose the shear force at C will be 0, then load at point C, then will be 0. So at point C, what will be the load then? Total load, we learned already. Total load, this is the triangle, right? This is the triangle. So total load will be half x into if it is the 6 kilonewton. So here will be how much? Here will be 6 by 9 into x. If you tell so here the height will be how much it will be height. I draw it for you. If you don't understand, I think it will be confusing for you, so I draw it and for you and make it clear. So at 9 meter distance, our beam is 9 meter, total is 9 meter, beam is total 9 meter, and at 9 meter distance we have 6 kilonewton by meter, 6 kilonewton per meter is the force, is the load. So we want to find what is the load at x distance, at the distance of x. So half, the total load is half, x is the our base, and what is this? How much? And we can find it like this way. For 9 meter length, it is 6 kilometer height, 6 kilometer. So 1 meter, it is 6 by 9. So x meter, it is 6 by 9 into x. So height is 6 by 9 so this is actually 6 by 9 into x. So more simply it is 2 by 3 x. So the height is 2 by 6. So we can write here 2 by 3 into x, and then we can calculate and then we can calculate this, cross cancel out, 1/3 of x square. So x square by 3. So total load is total load at distance x equal to 1/3 x square. So total load is 1/3 into x square kilonewton. So total load. So since the shear force is at the distance x is supposed to be 0, so we assume shear force here is 0, right? If we assume the shear force is 0, now we calculate shear force at C. The shear force at C is VC equal to, so we can calculate the 9 upward force is 9. So here upward force is 9, and up to this is downward force, and downward force is 9. Let me delete it and make a fresh calculation, or I can open a I can do it the fresh calculation here. How to calculate the shear force? Okay, how to calculate the shear force? Now here, so x is equal to 0. So x is equal to 0. So VC, we know at C point, we assume already at C the shear force will be 0. So if we calculate at V, it is 9, shear force is 9 minus this is the total force. Total force is how much? Total force is minus x square by 3 equal to, we already know it is 0. Already know 0. So here is only unknown. We have x square, right? We have x square. So solve this problem for x and tell me what is the result for x. Tell me please. You don't need to tell me. If you calculate, and you will find it is x equal to 5.2 meter. I already calculated for you here, 5.2 meter. That means from here to 5.2 meter distance, our shear force will be 0. So now we can draw it like this. It is 9 shear force diagram, and 5.2 meter shear force will be 0. And we already know this the line will not be like this. Line will not like this, but line will be inclined, parabolic. So we draw a parabola. Wait a moment, please. So we draw a parabola. So we draw a parabola. It is not a straight line. It is not a straight line. It is not a straight line. It is a parabola. After that, so see, here is 0. Now here's at the C point is shear force is 0. All right. Now if shear force is 0, now here shear force is 0. Now how much total force? Now what is the shear force here? Now we draw shear force at VA, and was 9. VC equal to 0. Now we draw shear force at VB. Now VB is shear force 0. Now, how much total force here now? I draw it again. I delete it. Now here, now 0, right? 0. Now up to here, so what is the total force up to here? Up to here was total force. We can calculate, right? So we can calculate 2 third into x equal to 5.20. So if you calculate the force, how much force will come here? Can calculate the total force will be 5.20. So here force will be 9. Here force will be 9. Okay. Now, how much force is here available? How much force is here? How much force is here? So how much force is very easy. If you calculate up to here is 9. So total force was 27. Total force was 27. So I draw it again. The red, another color. I draw it. So up to the green area. The green area, we know this will be 9. And how much this red portion? How much will be this red total load here? Because we know total load is 7, total load is 27, and up to this one is 9, so minus 9. So this area will be 18. This area will be 18. Now, how much the shear force at VB? At VB. Well, how much would be VB? So we have at VC, we have here is 0, then minus 18. So minus 18 at V, just left side V 18. So V left side, right side will be how much? We have minus 18, and then we got the support force plus upward plus 18. So plus 18, finally 0. So from here to here we go minus 18. Again, this is parabola. This is parabola. 18 and then 18 and then up 18. So 0. So finally our shear force diagram is drawn. This is plus, this is minus. Okay. Our shear force diagram is already completed. Now, so shear force diagram. So anyone has any question? Tell me. We have finished the shear force diagram. Tell me please. Please tell me if you have any question so far in this problem. Please tell me. And within this time, if you don't have question, so I ask you name call, right? So we finish it today. No, it is which day? 12th of November. So 12th of November, we should everyone is there. So today is Sunday. Today is Sunday, right? Yes. What is this? 1736, what does it mean? Hossein Jawad, tell me. I don't understand. 1736, I don't understand. Okay, so shear force diagram, if you have any question you can ask me how to draw the shear force diagram or how to draw. So within this, then sorry, now I draw the now response name con please for attendance. Muhammad Habis. Muhammad Habis is there, right? Muhammad Abdul Aziz Mazen. Muhammad Abdul Aziz absent. Kumail Ashraf. Kumail Hussain absent. Muhammad Abdul Aziz Hussain. Muhammad Abdul Aziz ibn Hussain. Muhammad Abdul Aziz. Yes, you are there. Uh, Muhammad Ahmad bin Abdul Rahman. Yes, fine. Then Muhammad Yusuf bin Muhammad. Kumail is here, right? Kumail is here. Muhammad Yusuf is there. Muhammad Sami bin Ibrahim. Muhammad Sami bin Muhammad Sulaiman. Good. Ahmad Tahir. Ahmad Tahir is there. Okay. Abdullah Muhammad. Abdul Malik Khalid. Then Omar Abdul Aziz. Omar Abdul Aziz. Omar Abdul Aziz. Omar Abdul Aziz absent. Ali Abdul Munaim. Ali Abdul Munaim is there, right? Isa Abdullah ibn Isa. Isa Abdullah ibn Isa. Isa Abdullah absent. Yahya Abdullah bin Ali. Yahya Abdullah. Muhanna Walid bin Muhanna. Then Tolal Jamal. Saud Usama. Tolal Jamal. Saud Usama absent. Hussain Ali bin Hussain. Hussain Ali. Yes, there. Faris Fahad bin Faris. Faris Fahad. There. Abdul Ilah Fahad. There. Right? Abdul Fahad. Yeah, yes. Then Ali Jawad bin Haji. Ali Jawad absent. Hussain Abdullah bin Bakir. Ahmad Imad bin Ali Muhanna. Abdullah Saadun bin Abdul Rahman. Abdullah Saadun. Ahmad Dia. Muhammad Salah. Hussain Jawad. Faraz Fadil or Firas Fadil. Faraz absent. Abdullah Saleh. Who is Umar? Umar Abdul Aziz. Abdullah Saleh. Saad Muhammad. Abdul Munaim. Abdullah Saad bin Abdul Rahman. Umar Wahid. Muhammad Shabir. Shamsan Saleh. Umar Ahmad bin Umar. Umar Ahmad absent. Jamal Raid, Kamal Ashraf, Umar Usama, Abdullah Abdul Nasir, Musa Muhammad Isa, Musa Muhammad Isa, Musa absent, Abdullah Saeed, Abdullah Saeed, Abdullah Saeed absent. Now I double check. Abdullah Aziz Mazen is there. Abdul Aziz Mazen, Abdul Aziz Mazen absent. Umar Ashi is there. He is there. Okay. Isa Abdullah, Isa Abdullah absent. Saud Usama absent. Firas Fadel absent. Firas Fadel absent. Musa Muhammad Isa absent. Abdullah Said absent, right? So double check, your name is not ticked there, so I confirm it here now. All right, done. Now let's see. Okay, so if you don't have any question for the shear force diagram, now we go for the bending moment diagram. We go for to draw bending moment diagram. Now you remember I told you that very important thing, that the point where shear force is 0, bending moment is maximum. You remember this. You must have to remember all of your life. This is very important conclusion, that I write down it for you, and you remember always. You must have to remember that shear force diagram, the maximum bending moment is maximum where shear force is 0. So here is shear force 0, so there will be the max bending moment is maximum. Now how much will be that maximum? How much? So we calculate. So maximum moment max equal to, we learn the bending moment is just area of the shear force diagram. So area. So what is the area of this? You already know, for triangle, you know there is a half base into height. But for parabola, what is the area? You don't know. I know you don't know, but I will teach you the next chapter. We will go next chapter. We will learn in detail. But here, only for here, I tell you, this is 2/3 B into D. What is B? B is here and D is here. D is here. Okay. So 2/3 B. What is the B? What is the B here? Our B is 5 point, this distance 5.25. B into 5.20 into D is the here 9. So 9, and then you calculate. We already have done is 2/3 5.99 equal to 31.2 kilonewton meter. Okay, so 31.2 kilonewton meter. So other way we can calculate in another way. Doesn't matter. Another way, how can we calculate? This is the one way we calculate the maximum moment here. So maximum moment is there up to here, there, and then we know this will be going to the 0. So this is into 0, right? Now here m equal to m. If we calculate the another way, is suppose we take moment at x distance here. We cut it down and take that side and take. So for at the x distance, we take the moment at the x distance, and the moment will be 0. So if we cut here, there will be the external moment m. So m, what is the m? Equal to 9 moment for moment 9 into x, 9 into x, and it is the moment the 9 is rotating clockwise, so it is minus, okay, plus. So we have the force here, right? Area is how much? Half x into 2/3 of x into the force will work, the force will work at the 1/3 distance as we learned. So 1/3 distance of x, so equal to force will be, we know here will be the moment equal to, because we assume the equilibrium was 0, so 0. And then so m equal to, we found how much? If you calculate m equal to 9x minus x cube divided by 9. Now if you put x equal to 5.23, 5.2, then we'll get this result. So this result is same, okay. So we draw the then shear force diagram, okay. So any question? Sorry, bending moment diagram. Any question you have? Tell me please. So if you don't have any question, so one question I ask you, this is very important thing on diagram. So how do you, now here one thing is, one problem is here, right? We draw this diagram, we draw this diagram in this way. Why not we diagram is this way, or why not we didn't diagram this one this way and this one this way? Why not we draw this way and this way? Instead of that, we draw here, we draw the diagram this way and this way. So the answer is there, right? Answer is there, right? If shear force diagram is, if our load diagram is look, so what will be the which line we should select, now I show you here. Now we know this is parabola, so this is parabola. This curve we have drawn like this, right? Our shear force is like this, but my question is why it is not like this? Why not like this, and why it is this? So the answer is, if you want to know the answer, so we need to go, we have to learn here, we have to see the shear force diagram. If our load diagram is negative, you see, first to select the which curve will be like this or like this, curve will be like this or like this. To select curve, so curve will be like this or like this. To select curve, we need to see the, for shear force diagram, we have to see the load diagram. So load diagram is what you see, our force is, what is happening? Force is downward, right? Force is downward. So downward force we assume always negative, right? And force is down from 0 to, it is slowly increasing. So what is our shear force load diagram? Our load diagram is, load is negatively increasing. So if our negatively increasing, our load is negatively increasing, so our shear force will be this one. So negatively increasing. So we will select this line. So if we select this line, so we select this line. So we'll select this line. So we select this line. So that's why it is like this. Similarly for bending moment, now you see, for bending moment we have to see the shear force diagram for bending moment. So bending, what is happening? It is plus. positively, it is plus, and now it is decreasing, it is positively decreasing. So if it is positively decreasing, so let's go there. Which curve? Positively decreasing. So positively decreasing, this curve. So curve will be like this, and then actually see, of course, curve also like this. See, curve is like this. So we stop here. Then what is happening there? It is negative side, right? So negatively increasing or decreasing, from 0 it is negatively increasing. So negatively increasing. So negatively increasing is this curve, negatively increasing this curve, right? So again, this also this curve. See, curve is like this. So that's why our curve is like this, not like this. Okay, curve is like this, not like this. So this is the reason, and this is a very important diagram. You need to keep always remember, right? You must have always keep remember. So any question so far? Do you have any question? Do you have any question? If you don't have any question, I tell you something important. So see here also the example I have shown you there. Here you see our force is negatively. Here you see this diagram. The example again I show you. So bending moment diagram. This is bending moment diagram, and this is shear force diagram. Now the line, why it is like this? Why not it is like this, right? Why not like this? To see this one, you have to see here. So it is what? Plus, positive, and this is slowly decreasing. So negatively decreasing. If negatively decreasing, which line we have to select? Let's go back. Sorry, go back. Negatively decreasing. Which one? Negatively decreasing. So line is negatively. Sorry, now positively decreasing. So positively decreasing. So line is this one. So this line, so line with this one. So here, so we select positively decreasing. So we select positively decreasing. This one, correct? Not this one. So when in exam, so you have to be careful. You draw this curve or this curve. You have any question? If you don't have any question, so I go back to this is the end of this chapter. So I just review something. So this is the shear force we learned it. Now this problem we have skipped. Now I leave it for you. You do it, right? Here they determine the internal force. Shear force diagram. Alhamdulillah. So shear force and bending moment diagram acting on point B. This point, at this point acting on B, two force member. So two force member, what is this? As I told you, this is the distributed load, UDL. UDL means uniformly distributed load. Now how it is, we have to do is, you see, first we need to find the support reaction. So how can you get the support reaction? For getting the support reaction, you take moment at A. If you take moment at A, and if you take the moment at A, so we have the force. I draw it. I make it. So I'm doing it here because it's simple, I think. So you can do it. So we have how much force we have there? How much force total load we have? We have here 50 kilonewton. 50 kilonewton into 8. 4 plus 4. 4 plus 4. 8. So total load is 400 kilonewton, and this force will be working just at the middle, at the middle, as we know. So 400 into distance is from here to here is 4. So moment is 400 into 4. 400 into 4, and then we have here, if you take the free body diagram of this, we learned from before. If you take the free body diagram, we'll see. So the free body diagram of force will be this one, and here will be this one. So this one, this direction, right? So, or if we draw, if we think that our force will be this one, this direction, so this one will be that direction. Simple, right? And the slope will be, what is the slope? Slope will be the this will be 5, and this is the 3 and 4. And then so 3 by 5 into the force distance, and so FDC equal to, we find FDC equal to 3.33. so if you calculate, you get this value, right? Now what is the axial force? So if the force is now you got, this is our member and the force is working here 3.33. So what will be the our force? So one force will be there and another component will be there. So ax sorry, x will be, so x not ax, so this direction force will be, so 266. How? So 333 into, so into is 4 by 5, and you will get, this is 2.667 kilonewton. All right. And vertical force, you will, how much you will get the vertical force? This is and vertical force equal to, this is 3 by 5 into 3.33, and this one is like how much? So 3 by 4.6 into 3333.3. So 200, almost 200. So here is, you will get 200. All right. So shear force is here. Now when we calculate the shear force, so ax equal to now, the question is find the internal force, shear force, and the bending moment. Now shear force is how much you got there. So minus at this point as I told you, ay, this ay, the support reaction here, ay means usually we say ab, ay minus 400 total force here, 200 here for distance, right? Here is 50 into 4, so you know, so 50 into 8, so 400 plus and this 800. So finally ay is the 400 force, right? Then moment, what is the moment? So moment, if we do the summation of vertical force, if we do summation of horizontal force, it will be 0. So here is this is force, axial force. So axial force is how much? Axial force minus, so NB, suppose we give them NB minus the AX. So AX was, we calculated how much? AX we calculated 2.667, right? So AX is equal to, right, this. Now Fy, if we want to this, and this is the shear force, as I said, this is the sliding cutting force. So we have 200 is the upward force, minus 200 is downward force, minus shear force. So shear force equal to, we got here actually shear force will be 0. There is no shear force. And moment as I told you, here is the moment. How much? We assume that when we take the free body diagram of this part. So one is the NB, another is the BB, and another external force will be moment. So BB equal to 0, NB equal to, we calculated 266.7, and now moment, how to calculate moment? So this moment, we assume this is the anti-clockwise, and the anti-clockwise plus MB minus 200 into, we are taking moment point at B, because we are we want to find the external bending moment at B. So we take the moment at B into 200. So 200 into 4, and this is the clockwise. So minus, then minus 200, then minus 200. This is the force into 2, and it is also it is minus 200 into 4, minus 200 into 4, and this is minus 200 into 2 from this distance. All right, equal to 0. So we got the how much? 400 kilonewton. Is 0 is the our external moment, right? So here it should be plus actually, because with this respect it is plus. So plus, if we do it minus, it will. So any question so far? Any question? So this is the 7.3 was our I skipped at the beginning, so we solve it now here. All right, any question you have? Do you have any question? If you have don't question, I skip something intentionally. Now I will show you some relationship, right? Here the relationship between the distributed load, shear force, and moment, right? So here there is some mathematical problem, mathematical things. So that is not important. Important thing is this. This kind of theoretical thing, but the you need just telling you the slope of the shear force diagram is equal to slope of shear force diagram. As I told you, slope of shear force diagram is if it is vertical, it is considered load, so slope of shear force diagram is straight 0. If it is uniformly distributed load, so shear force diagram will be inclined. Shear force diagram will be inclined like this or like that. Okay, now shear force moment diagram, shear force, so moment diagram is slope of moment diagram is equal to shear force. How it is? So if shear force diagram is our slope, like this zero slope, then bending moment diagram will be like this or like this. If it is inclined, so it will be like this or like this. Okay, so this is the something relation I wanted to tell you. Okay, now do you have any question? I'm asking several times, do you have any question, so this is there is some example problem already completed. The problem, it is for you practice problem, you do it by yourself, right? Not yourself, it is already done here. Example also, answer also given, so you practice for practice, right? It is practice also given in the practice problem, right? So this is here the end of this chapter today. Next class we will start chapter 9. Remember chapter 9. Chapter 8 we will skip. Chapter 9 we will start chapter 9. All right. Any question you have, tell me please. So shear force bending moment diagram we already learned there, right? And don't be confused, this is, we ignore this, right? The camel chapter 7.4 is not, we skip, right? We skip this, we skip with our study up to here, and this cable we skip it, we skipped, this is we skipped, right? Skipped. Okay, so if you don't have any question, so we can finish here, right?